All right, hello. We are doing a sex chromosome lab. We're starting this actually in class with my hybrid kids, and this will be a little help for my remote kids who I didn't get to go over this. So we're going to do a lab on sex chromosomes, the XX for females and the XY for the males. So the problem or purpose of this lab is how are traits on sex chromosomes inherited. There are two we're going to discuss today, do the lab about. One is hemophilia. We did talk about this. It's a disorder in which a person's blood will not clot. Sometimes they're called bleeders. If you have the dominant gene, big H, you're going to have normal blood. But if you have the recessive gene, little h, your blood will not clot. Color blindness is another genetic disorder. We'll talk about, usually the person doesn't see red and green is the most common one. They see green as gray and red as yellow. If you have at least one dominant gene, big C, you see all colors. If you have only recessive genes, you cannot see red and green. So both of these disorders are recessive disorders. You have to have all recessive alleles to have these disorders. So you're going to toss coins to show children of 5 different families and see how it's inherited in several families and solve some genetic problems about them as well. Here are the keywords if you want to pause it and jot these down. The definition of color blindness, hemophilia, and then I have sex chromosomes, male XY, females XX. Like I said, pause this to write those down. You're only going to need 2 coins for this lab, some tape, preferably masking tape. So the first family has hemophilia. Now this hemophilia and color blindness are both sex-linked traits. They're on the X chromosome. Remember, guys only have 1 X chromosome. Girls have 2. So a female can be X big H, just like purebred normal. X big H, X little h, which means she's normal, but she's carrying the hemophilia gene. She's a carrier. Or X little h, she has hemophilia. A male can be X big HY normal or X little hy. So in this family, both parents are normal. Dad's normal. Mom is a carrier. So that's where you have to put the coin 1, X big H on one side, Y on the other, X big H on one side, X little h on the other for mom. And I want you to toss those coins. I'm going to skip down, not 40, but 10 times. Toss those coins 10 times. Now, if you did this Punnett square, let's do this Punnett square here real quick. If I did this Punnett square, I've got X big H, Y, we'll pretend that's dad right there, and mom is a carrier, so she's X big H and X little h. So if we fill out this Punnett square, we can see what we could get. We could get X big H, X big H. That would be a female that's pure normal. We could get an X big H, X little h. That'd be a female that's a carrier. We could get X big H, Y. This is a male that's normal. Or you could get X little h, Y. So if you look at all the choices of things that you could get X big H, X big H. We could get X big H, X little h. We will never get X big H or X little h, X little h. You'll never get a female. In this scenario, you'll never get a female with hemophilia. You could get X big HY. You could get X little HY. So you need to flip the coins and put the tally marks in here. Remember tally marks, once you get 5, put a backslash. So put whatever tally marks you get from flipping the coins and then write down what totals you get over here. So obviously don't write these down. I'm just showing you what tally marks look like. That's scenario number 1. Family number 2. Now dad has hemophilia. He's got the big H here. Highlight that for you. Dad has hemophilia. And mom is a carrier. Ooh, this does not sound like a good scenario here. I set up the Punnett square for you. This is what it looks like. You'll have to make Punnett squares for all of these. But if you do this Punnett square, you'll notice that you never get a purebred normal female. So do that again. Again, only 10 times. Flip the coins 10 times. Tally. Tell me what you got for each. The next two scenarios deal with color blindness. Dad is colorblind. Mom is normal. Again, you need to do a Punnett square. Punnett square, dad goes on. Dad's going to go on one side and mom's going to go on the other. Figure out which one of these you won't get. Actually, on this one, you won't get a few things. You won't get, I don't want to give it away, but you won't get 3. You only get 2 out of the 5. The last scenario is dad's normal, mom is a carrier. This is actually a scenario my cousin Luke, his parents are. That's why he is colorblind, actually. The last questions, you're going to have to make a Punnett square for. So here's number 1. Actually, I did number 1 for you. So 2 parents. One parent is mom is a carrier, dad's normal. Here's mom's a carrier, dad's normal. So here are the 4 different outcomes you could get. So for each of these males and females, it's going to be 2. Obviously, it's going to be 2 of each. So let's do this first question with you. So out of these 2 males, this male would be normal. This male would have hemophilia. So I would write 1 and 1. Out of these 2 females, normal, because she has 2 big H's. This one's normal because she has 1 big H. She's a carrier, but she would be normal. So she would have normal clotting. So the answer to this would be 2. Neither female would have hemophilia. You're going to have to do a Punnett square for these 2, mom and dad. Question 3, you're going to have to do a Punnett square as well for color blindness. Then there's some questions on the bottom. These questions right here, 8 and 9, think about these. Which of the parents give the trait of hemophilia to their son? Sons get it from who? They have 1 X chromosome. Where'd that X chromosome come from if you're a son? Daughters, if they have hemophilia, they have 2 X chromosomes. So they had to get them. Where'd those X chromosomes come from? They had to get them from 2 different people. And that is, I don't know if I want to go over any of these other ones with you. Why is there a difference in the number of genes for blood clotting in males and females? Remember, females have 2 X chromosomes. Males have only 1. The genetic disorders, color blindness, and hemophilia were the genetic disorders. And remember, in problem 2, why are there no colorblind children? Well, if you look at question number 2, mom is always going to give that big B gene. So hopefully that helps you with this lab. If there's any questions, help class, email, and